These are you're going to see words like less than and. So we talked about compound inequalities last class, and we said that if it's an and statement, that's the intersection, and if it's an or statement, then that's going to be the union. So we're going to start with and first, but these are going to be absolute value inequalities. So we've done equations, but we haven't done inequalities. So let me go over the steps. So the steps: still isolate your absolute value bars, remove the absolute value symbols, okay, and then write the compound inequality problem. Okay, so go ahead and write those 3 steps down. Okay, this is page 13 again. And then we'll go through the steps of working some questions together. Okay, so I'm not going to start with number 12. I'm going to actually start with number 13, and then we'll come back and do number 12, all right? So in number 13, step 1 is actually already done because the bars are already isolated. There are no numbers outside of the bars, so that's already done. So step 2 says you're going to remove your absolute value symbols. So let's remove them and write the problem exactly like we see it. And now, since we don't actually see the words and we don't actually see the word or, because these are absolute value inequalities, it's going to be based on the symbol itself, like the less than symbol. So less than or less equal will be for and. All right, and that's at the top already, but in case you want to, just kind of stress that, the and now will be for the actual inequality symbol. So think of less than, you almost hear and in less than. And now you have to do just like we did with equations. We're going to have to separate it into 2 parts. So when I rewrite it the second time, okay, this part never changes. The part that's inside of here never changes. It's still going to be x plus 1. When you write your second one, you're going to reverse the symbol to greater than, and then you're going to make that a -6. So that is how, see, remember when we did equations, we set it equal to 6 and -6? Same thing here, except for you also have to reverse the symbol. All right, and then you just solve it. Okay. Now, this is, and I'm going to show you an optional way because I think it's easier. I'm going to show you another option of doing this. Okay. Now, then you would have to take it and put it in set builder and all of that. Now, let me show you, and let's go ahead and finish this off. So in set builder notation, this would be x such that -7 is less than x, which is less than 5. Okay, because remember in set builder notation, we start with the smaller number to the greater number. All right, so that's one way to solve it if you want to separate it into 2 parts. Okay, now I'm going to show you an optional way, which I think you'll find easier. And the optional way will be the way that I'll be solving the rest of them. Okay, but I always like to give you a choice in case you feel like, I want it separated instead of writing it as a compound inequality. But I think writing it as a compound at the very beginning will be easier. So let's do that. So I'm going to erase mine, and you can put yours somewhere else, okay, off to the side or somewhere. So this is the second way of solving that same problem. So since I know this is common for both, that's going to go in the middle. Okay, I have my less than symbols. I put 6 over here and -6 over here. So I've written it as a compound inequality versus separated into, individual inequalities. So this is an option. So then you would just do this to all sides. And now you'll have -7 is less than x, which is less than 5, which is what I had before. Put it in set builder notation. So you'll put your bar and you write the x again. Okay, now I find this a little bit easier. Okay, but again, you have the option to either separate it yourself or just write it as one inequality, compound inequality. All right. All right, so I'm going to do 14, then we'll come back to 12. So in 14, we're still dealing with all the less than and statements. So first thing I got to do is isolate the bars. The bars are not isolated because there's a times 6. So what should I do? It's a times 6. Right, so we're going to divide. That's right. So when I do 78 divided by 6, that's going to give me 13. So I'm going to have this as my problem. So I'm going to write it as one compound inequality. So I'm going to say negative 13 is less than negative 8x plus 3, which is less than 13. Okay. All right, so we can solve this just like it is. So let's go ahead and subtract 3 from all sides. Okay. So that's going to give me, and I'm just going to write it down here, negative 16 is less than negative 8x, which is less than 10. All right, and then just divide by the negative 8. But what's going to happen since I'm dividing by a negative 8? Yes. Right, so we're going to reverse the symbol. So this will actually give us, if we reduce 16 over, that's going to be 2, right? So we're going to say 2 is greater than x, which is greater than negative 5/4. Is that correct? Yes. So now this is not in set builder notation. Why? Two things. They're greater symbols, and then your least number is not written first. So now we reverse it again and say negative 5/4 is less than x, which is less than 2. Okay, and we put that in set builder notation. Okay, let me. All right, so if we go back up to number 12, very easy because the bars are already isolated. And so all I have to do is just say, to write it as a compound inequality, negative 9 is less than or equal to r, which is less than or equal to positive 9. Put it in set builder. Okay, so there was really nothing else to do to that, okay, except for just put it as negative 9, positive 9. All right. We didn't have to isolate anything or solve. All right, let's go ahead on to number 15. Okay, now in number 15, there are a couple things I got to get rid of over there with those absolute value symbols. The 8 and the 5. I cannot add 8 and 5 together. They're separate numbers. So I start with the positive 8. So I'm going to subtract 8 first from both sides. Okay, so don't make the mistake of trying to combine those together. You cannot do that. So I'm going to have 5 times the absolute value of 10 minus 10n is less than or equal to 100. Okay, then I'm going to divide both sides by 5. So I'm going to have the absolute value of 10 minus 10n is less than or equal to 20. So I can write that as a compound inequality. So I'm going to put negative 20 is less than or equal to the 10 minus 10n, which is less than or equal to 20. All right. So now we can just go ahead and solve this. We'll subtract 10 from all sides. So that will give me negative 30 is less than or equal to negative 10n, which is less than or equal to 10. Okay, what will be my next step? Divide by negative 10, and since it's negative, I'm going to be reversing the symbols. So that's going to give me positive 3 is greater than or equal to n, which is greater than or equal to negative 1. All right, now I'll flip the symbols back to write the numbers in order from least to greatest. So it'll be in set builder notation, and such that negative 1 is less than or equal to n, which is less than or equal to 3. All right, so these are special cases. so you'll know. So what's going to happen here, if you notice that this says the absolute value of something is less than a negative 58. That is not possible to take the absolute value of anything and get a negative answer. So this would be a no solution type of problem. Okay, because it equals 2 or because it's less than a negative, you cannot have less than a negative number. Okay, so that's why it's a special case. So if you isolate your bars and it comes out to be less than a negative number, then you want to say no solution for that. Okay, same thing for this one. The same thing is going to happen here. Okay, we can just work this out. But what you're going to have is less than or equal to negative 20. And even if you divide by this 8, you're going to end up with a negative number. So this is also no solution. Okay, now if that had been a negative 8 and I divide a negative divided by a negative, that would have been a positive, that would have been okay. But since it's less than a negative, then you want to say no solution for that. Okay. Yeah, it's negative 24. It's still negative. You're right, negative 24. All right, now let's move on down to the or statements. And really, the steps are the same for the or, so I'm not going to rewrite them. It's the same 3 steps that you wrote for the and. So for greater than, now you have to know for the greater than symbol, that's going to represent or. So I say greater. I know it's greater, but you know, little British accent there, greater, then that's the or. All right, so then because it's going to be very important to know whether it is an and or an or, so that's why you need to make sure, you know, you're able to distinguish, well, when is it an and, when is it an or. So less than, and, greater, or. All right, so let's just take a look at some problems. Now these you don't have the option. You do have to write them as separate problems. So for and, you could write it as one. For or, you do have to write 2 separate ones. So let's go ahead and start with 21 first. So the bars have been isolated. I'm going to drop the bars and write it as 1 minus 2n. Exactly like I see it first. So now I'm going to say or 1 minus 2n is less than or equal to negative 3. All right, so now you don't have the option of combining the negative 3 and positive 3 together. It has to be written separately. Okay. All right, we haven't gotten there yet. So now we're going to solve it. So we're going to solve for, yes, we did flip the side. This was a greater than symbol. Now it's a less than symbol. So now we're going to go ahead and solve this. And we're going to do minus 1, minus 1, minus 1, minus 1. Okay, so that's going to give me negative 2n is greater than or equal to 2. And this will give me negative 2n is less than or equal to negative 4. All right, now we're going to divide by negative 2. So we are going to reverse the symbol. So that gives me negative 1. Divide by negative 2 here. Reverse the symbol. That's going to give me what? Positive 2. All right. And then we just put the word or between the 2 answers. And we put it in set builder. And that's it. All right. So they're going in opposite directions. You guys already know how to graph. So I haven't been making graphs for these, but I'm sure you know how to, graph that to the left and graph this one to the right. Okay. So, that lesson we've already covered on graphing. Okay. All right, let's go ahead and do question number 22. Okay. So in question number 22, what do we do first? Because you guys should at least know how to solve it. We have to isolate the bars. So what is the first thing I would do? Yes. Multiply by 10. Very good. So we're going to multiply both sides by 10. So that's going to give me the absolute value of negative 4 minus 3x is greater or equal to 40. So now I'm going to drop the bars and write my two problems. So I'll write it exactly like I see it without the bars first. Okay, or -4 minus 3x is less than or equal to -40. Okay, so those are the two changes you make. Okay, the -40 and reverse the symbol. All right, so I'm going to let you all solve that, and we'll come back and see what you get in a minute. Okay. All right, so that's what you should have. X such that x is less than or equal to -44 or x is greater than or equal to 12. And it doesn't matter which one you write first for or. Okay, so that's not important, so it doesn't matter. I will do one more of these or problems. Let's do 23. Okay, and then we'll do some special cases for or. All right. All right, so in 23, who can tell me what to do first? Got to know where to start. Okay. All right, go ahead. What should I do first?
Divide by 7.
Oh, we're going to add 3 first. Anytime you have positive and negative numbers, you always want to do those first. Okay, so we got to get rid of that -3. So we're going to add 3, and so we'll have 7 times the absolute value of 10 plus 8x is greater than 14. Now we can divide by 7. So that will give us 7 times 10 plus 8x is greater than 2. All right, so I'll let you all finish that, and then we'll check to see what you got as your final answer. So just like we had special cases for and, here are some special cases for or. Okay, so we'll write special at the top. So these two are special because it says that it's going to be greater than a negative number. So that means all reals. Okay, or you can put the real symbol. Same thing here. This says greater than a negative number because obviously absolute value of anything is going to be greater than a negative number. So that means all reals. Okay. So those are special cases as well for your greater than symbols, the or statement.